Good morning, class. Happy Tuesday. Welcome to our final unit of math for the year. So today we are starting to work on volume, okay? And this is something that you have seen before, so you should be a little bit familiar with it. So I want to review with you how we find volume, okay? So for example, this cuboid, and a cuboid is anything that is a box shape, has 60 cubes. And I've made this with 4 by 5 by 3, okay, cubes, okay? But this also has 60 cubes, okay? And I made this one with layers of 6 by 5 and then by 2, okay? So if our volume is 60, we can find the volume by multiplying the length and the width and the height, okay? And so you can see that here as well. So if we took this and did 2 times 6 times 5, that equals 60. So that's for this one, okay? So I have my 2 times 6 times 5, okay? Or this one would be 3 times 4 times 5, which also equals 60, okay? So you might remember that from last year that the formula for volume is this. For the volume of a cuboid, volume equals length times width times height, okay? So that should be review for you. So now I want to remind you that if it's by 1, then it's basically 3 times 4. So the volume of this cuboid is 12 because it's 3 times 4 times 1. So if the height just has one value, then it makes it easier for you, right? Okay, but what if we have shapes that are not perfect, right? What if we stuck these two together so that we had this 4 by 3 and this 5 by 4 by 3? We would want to add them together and still use our volume formula to find the total volume of this cuboid, okay? So let's look at that together in the textbook. So we're gonna open our textbooks to page 80, okay? So make sure you have your textbook, and I would like you to get your spiral book out too, because we will be writing this down as well, okay? Because I want you to remember it. So you can even start in your spiral book by writing your volume formula. Even though you have it on your anchor chart, it's helpful for you to write it down so you can remember it, okay? So you should have the date and the title, okay? And then just start by writing volume equals length times width times height, okay? And of course, pause the video if you need to, if I'm moving too fast for you. But then we're gonna go to textbook, page 80, and look at how we can figure out these volumes, okay? So again, if you need to pause the video to write this down, please do, but otherwise, let's have a look at this. So 2 of these cuboids are nice and easy, B and C, and we'll be able to do those just using our formula. But A and D, we're gonna have to try a little harder, right? We're gonna have to do something different. And I want you to think about how you might approach, specifically, let's look at A. How can we find the volume for A? Okay, and what I don't want is to just count up all the cubes, okay? I know that's one way that it could work, but we're trying to use formulas, right? So let's try to apply our formula to this cuboid, okay? So let's look. So the base set is 4 times 4, okay? And it's times 1, so we can do that. Okay. And then we're going to add the next level. And remember, bed mass, if I put it in the brackets, it has to be first. Okay, so the next level is 3 by 4, also by 1. Okay, so 3 times 4 times 1. And then the next level, we have 2 times 4 times 1, and then 1 times 4 times 1. Okay? So let's do the math for what's in the brackets first. So 4 times 4 times 1 is 16. Okay, 3 times 4 times 1 is 12. Then 2 times 4 times 1 is 8. And then, of course, 4. Okay? So now we can add these up together. So we're going to get 40. So the value of A is 40 cubic units. Okay? 40, we could even write 40 units cubed. And remember, this little 3 shows us that it's cubed. Okay, so all of your answers should have the unit and then cubed. Okay, so let's look at B. So B is a nice cuboid shape. So we can just fill in the length and width and height. So the length is 4. And then the width is 3. And then the height is also 3. Okay? And when we're looking at length and width, it doesn't really matter. If you want this to be your length, that's totally okay. If you want to look at it from the top and have this be your length and width, that's totally okay. It's just having the 3 different dimensions of the cuboid. Okay? So 3 times 3 is 9. 9 times 4 is 36. So B is 36 units cubed. Okay. So now let's look at C. Okay, and so again, we see the front face and the side face, and we have 4 times 4, and then the height is also 4. So this is actually a perfect cube. So 4 times 4 times 4 equals 64, okay? Okay, because 4 times 4 is 16, and then 16 times 4 is 64. All right, now let's look at D. So D, we can split our interesting cuboid shape into 2 sets, okay? So just like for A, we split it up into 4 sets because the 4 tiers were different. For this one, we're gonna split it up into 2 sets, okay? And again, there's a couple ways to do this, but I'm gonna kind of shave off the front part. So I have 2 times 3 times 5 here that I'm using for this part, okay? So that'll be my first one. Okay, and as we go, I do want you to write this down so that you can see how it works. So again, if you need to pause the video to catch up, please do so, but I am writing this down so that you can write it down as well and understand how it works in your notes, okay? So for D, that's the first set, 2 times 3 times 5, okay? And then the back is 5 times 2 times 5, okay? So you have a height of 5, width of 2, and a length of 5, okay? So we'll add that, 5 times 2 times 5, okay? And then we'll do the multiplication in the brackets. So this is 30, okay, because 6 times 5 is 30, and this is 50, okay, because 5 times 2 is 10, times 5 is 50. So our total will be 80 units cubed. Okay. So do you see how that works? So when we're given a shape, we can evaluate the length and width and height to find the volume, okay? And that should hopefully be review from last year when you first were introduced to the volume formula, okay? And I want to draw your attention to this. So I've given you this as part of your anchor charts, and these are perfect cubes. So like I mentioned with C, 4 times 4 times 4, when all of the sides are the same, so when it's like length and width and height are all the same value, that means that it's a perfect cube. So pay careful attention in your workbook whether you're being told that it's a cube or a cuboid. Because a cuboid is like this, it's just a box shape. But a cube has all the sides being the same value, okay? And so you can see here for 4, we have it listed already that it's 64, okay? So say you were told to make all the sides 3, so 3 by 3 by 3. That puts our volume of this cube at 27, okay? So you see I have my length is 3, my width is, or my length and width and height are all 3, okay? And so this is my cube, and it has 27 pieces, okay? But what if we are given a volume and 2 dimensions, and what we're missing is not the volume, okay? So now we're gonna take it up a level and explore how that might work, okay? So let's build something worth 24 cubes, okay? And if we are given a length of 4 cubes and a width of 3 cubes, let's see how many we need. So I have my 24 cubes. And I'm going to rearrange it to make sure that the length and width meet the expectations. Okay. So here's a start with 4 as a length and 3 as a width. Okay, but this is just one level. So this adds up to 12. Okay, the area of this base is 12. So then I'm going to put my next layer up. Okay, so now I have the rest of the cubes added on to my base, and I found that my height is 2 cubic units, okay? But what is another way to find the height? We could divide the total volume by the number of cubes in the one layer, okay? So we know that our volume is set at 24, and we could divide this by the length and width that we've been given, 4 times 3, okay? And so we know that 4 times 3 equals 12, and 24 divided by 12 equals 2. So that is actually how we are able to find the height when we aren't sure what it is. We can take what we know, the length and width, and the volume, and we can divide them, okay? And so you'll actually see that on your anchor chart as well, okay? So it says here, for finding the unknown dimension, if the volume and 2 dimensions are known, we can find the 3rd dimension by dividing the volume by the 2 known dimensions. So for example, what we just did to find the height is in this circle. There's the volume over the length times the width, okay? And that means that if we're given the area for the base, because we know that area equals length times width, so I'm putting that over here. So we know this from our 2D shapes, right? The area of like a rectangle or a square shape is length times width, okay? So if we're given the area of one side and the volume, we can divide the volume by the area, because what we're doing is the same thing as we just did. we divided it by the length and the width. So for example, if we are going to make a shape that has a volume of 48, okay, and it has an area of 16, we can divide those to find the height of that cuboid, okay? Because the area we're assuming is length and width. So that means that we have the value of the length times the width, even though we don't necessarily know what it is. But like for 16, it could be 4 times 4 or 8 times 2, right? But it doesn't matter because we know the end result is 16 as the area. So what we're looking for is the height, or the third dimension. And third dimension, if we do 48 divided by 16, is going to give us 3, okay? So that is how you figure out, if you're given the area of one side, you can figure out the missing dimension, okay? And it might be height or length or width by doing this division, okay? So I hope you've written down that you can do this, volume over area. Okay, you don't have to write down this equation necessarily, but if you need to remind yourself that area equals length times width, please write it down. And I'm sorry I'm not color coding it to make it more clear, but take a moment if you need to and write this out, that you can do volume over area, and the area is length times width. And then we'll look at our textbook for some more examples. All right, so we're on page 81 now, and we're going to try all of these exercises, okay? So we have 1, 2, and 3. And the first one tells us that the volume of a cube is 27 centimeters cubed, and it's asking you to find the length of one edge, okay? And we know that when it's a cube, it's told us it said cube, so that means that all of the dimensions will be the same. Okay, they're equal to each other. So we can even just look at our handy dandy reference and see, where does 27 fit? Right there, which means the side value is 3. Okay, but you can see it as well here, right? So you can visualize it as well if you would like to. So you can also try to estimate which 3 things will multiply to get to 27. But we have this handy dandy reference to help us as well, okay? And you should familiarize yourself with this because it will continue to be helpful to you. So the answer for 1 is 3, okay? So there we go. We've checked that one off. So now let's look. The volume of a cuboid is 24 centimeters cubed. The length of the cuboid is 3 centimeters and its width is 2 centimeters. So find its height. So again, we can see visually they're showing us what it might look like, but this is the formula that we're gonna use together. And we're gonna do this now to figure out what the height is, okay? So this is where we have our 24, this is our volume, and we're gonna divide it by the 2 known dimensions. And in this case, it's length and width, okay? So we have 3 times 2, okay, which we know equals 6. And so 24 divided by 6 equals 4. All right, so the height is 4 centimeters. Okay, and because it's just one side, I'm not cubing it because it's just the height. So it's one value. The volume is where it has to be cubed, okay? So let's look at the third one. So the third has 2 tasks for us. And it's asking us to find the unknown edge of the cuboid. Okay, so we see that these are box shapes and we're given 2 dimensions for each of them. So let's look at that. So for A, we are given a volume of 576 centimeters cubed, okay? And we're gonna divide that by 8 times 8. Okay, and when you have a large number like this and you're like, oh my goodness, I'm not sure what to do, you can divide it by one of the values and then divide the answer by the next value. So I'm gonna do that over here. So 576 divided by 8 Okay, so 8 fits into 57 7 times, okay, and that gives us 56. So there's 1 left, and then 16. We know it fits 2 times, and that's 16, 0. Okay, so our first answer, so now we have 72. So now we can take 72 and divide that by 8. Okay, and 72 divided by 8, and this one we might be able to just do with mental math because it's part of our multiplication tables. It's 12, okay? No, it's not 12. It's 9, okay? So we can use our two-step process to do this division if it's easier, okay? And so our value is 9 centimeters. All right. Okay, so now B. B has given us the volume of 216 meters cubed, okay? And the two values that they've given us looks like height and length, and it's 6 and 3. So 6 times 3. Okay, so again, we can take this aside. We can do 216 divided by 6, okay? 6 fits into 21 3 times with a value of 18. So there's 3 left over, and 6. 6 fits into 36 6 times, okay? And that zeroes us out, okay? And now we can do 36 divided by 3, which we know is 12, okay? So the answer for this one is 12 meters. That's our missing dimension. All right, I hope you're seeing a little bit of how this works as we practice it together, and you'll be able to practice it more in your textbook. And now we're gonna come back to the idea that we can take volume divided by area. So we're gonna flip the page and we're gonna go to page 82, and we're just looking at number 5 on this page, okay? So this page, they've given us a volume and an area. So we are gonna take our volume and divide it by our area. So for 5A, our volume is 264 centimeters cubed, okay? And our area is 66 centimeters squared. Okay, so we have to do 264 divided by 66. And the easiest way to do this is, of course, to do the guess and check. And so I'm going to start by multiplying 66 by 2 to see what value that gets me. Okay, so 6 times 2 is 12, and 12 again, so it's 132. Oh, which is half of 264. So 66 times 4 looks like it might get us there. So 6 times 4 is 24, and 24 again plus the 2 is 26. Okay, so now we know that it's 4, and that is our answer. And we're gonna put it in centimeters because that's our value. And there you have it. So let's do one more. So B, they've given us a volume of 288 feet cubed, okay? And the area of one side is 72 feet squared. Okay, so again, we're gonna have to just try to do the guess and check method for our division. Okay, so I'm going to start by doing 72 times 2, just to see how big that gets us. Okay, 2 times 2 is 4, and 14, so it's 144. And oh my goodness, look at that, we've done it again. It's worth half of the answer. So we know that 72 times 4, 2 times 4 is 8, 7 times 4 is 28, and that gets us our answer. So it's 4 feet, okay? So there you have it. So now you've been introduced to two things: the idea of a missing dimension when given two other dimensions, and also the finding the missing dimension when you've been given the area of one side, okay? So it's your turn. Today in your workbook, you just have 2 questions to complete. So we're on exercise 53, and we're just doing questions 1 and 2. Okay, so just this page is your task for today because exercise 53 does continue here. But for now, we're just doing page 97. Okay, and if you have any questions at all, please feel free to reach out to me. Don't forget about your anchor charts as well and what we learned in our textbook. And then that will be math for today. Thank you for sticking with me throughout all of this.